So I'm going to be talking today a little bit about a project that we did this summer with two of my students from the University of Redlands, Adrian and Tessa. And our goal was to see if we could modify our data collection protocol to make it more efficient and also quicker and less prone to errors. So my overall research goals are to look at human impacts on marine mammals within the Southern California bight. And there's quite a variety of species that we see in this area. And we're trying to do a long-term monitoring to look at the distribution, behavior, and habitat use. For some of the animals that we can see include the blue whale that you can see in front of the bow here that visits during the summer months to feed on krill. We also have quite a few humpbacks that come to the area in the summer months. And on calm days, like you can see here, we also get a lot of people. This particular whale was actually feeding off of Redondo Beach for a few weeks. And after this day, we didn't see the whale come back. So I think this whale decided it had enough. We also see people who think that because they're on a non-motorized vessel that they don't cause any problems, and they look at it as a challenge to see how close they can get to these animals. Many times they have GoPros, they jump in the water, and clearly this can be a problem. There's gray whales that migrate along our coast. We are fortunate to see them from around December through April. And when they're migrating back north with their calves, they really hug the shoreline. And they tend to come into very close encounters with boats. And of course, we have a lot of dolphin species, including bottlenose, like this image, and common dolphin species. And finally, pinnipeds are pretty abundant. This is a California sea lion. Unfortunately, a lot of fishermen see them as a nuisance, and this animal, we think, was hit with a spear gun by an underwater fisherman. So with all these animals and all these people, there's obviously issues with disturbance. So we have been studying these populations and using a pretty traditional approach of going out in boats to survey for all the animals and the boats that we see. I work with a lot of students at the university who volunteer on the project or do capstone research. And I also have been working with Earthwatch expeditions, and so I take on volunteers during the summer months who spend about 1 to 2 weeks helping out. So there's a lot of different people doing this work, and that can lead to problems. One of the things that we do, of course, in addition to recording information about the individual animals, is take photographs to identify them, and then develop maps. And this is just an example of a map that summarizes one season's data on just the blue whales in relationship to boats. Of course, if any of you have done any field work for marine mammals, you probably realize that most of our days are spent like this, looking for animals and not necessarily seeing a whole lot. But when we talk about the methodology, we did originally use hand or pre-printed data sheets that we would write on with paper and pencil. And we had one for recording animals, one for recording boats. And these included basic information such as species, number of animals, behavior, and of course, location. These would then have to be hand transcribed into Excel. We'd also get the location from the handheld GPS, which had to go through Basecamp and DNR Garmin to get it into a form that we could then put it into ArcGIS. And it's not a very difficult procedure, but it was time-consuming. And we had very detailed instructions written out so that people who were new to GIS could follow along. And of course, we trained the people as well. But we discovered a lot of problems along the way. Probably the biggest one is the time. So this is one of my students, along with some Earthwatch volunteers. And you can see that a lot of people looking, not necessarily doing anything. But even with at least 2 people doing the data entry, it would usually take about 2 hours for every, say, 5-hour boat survey, which is a lot of post-processing. And many times, there would be mistakes. Somebody would save something incorrectly, and then the data wouldn't join. And we'd have to then go back and redo it later. And all of that was to eventually get one map per day that would show where we went and what we saw. And of course, each time it had to be symbolized for that particular trip. Another issue was the consistency of entering data. We learned early on that it was important to use all capitals, otherwise people would enter in all different ways, and when you do a query, it wouldn't find all the matches. But even after that, sometimes people would do things like, instead of putting the boat size in feet, which is what it was supposed to be, somebody decided to do small, medium, and large. Very unhelpful. Organizing a large data set. Where do you put all the files? So we'd have GPS files, and of course for each day there were 6 or 7 files. For each trip, we'd have Excel files. We'd have the maps we created. People would put them in different places. Finding them became somewhat of a nightmare. And then combining the maps. So we had all these nice, pretty maps from each trip, but how do you put it into one big map to do any type of analysis? So I had a student work on this last year, and her whole project ended up being trying to figure out how to do this. And many times when she would try, she got these nice error messages. So we worked, luckily, with some support from the Center for Spatial Studies at the university, and our short-term solution was to have a script to provide a unique ID for each entry so that we wouldn't have all these issues of overlapping data. And this worked. We were able to generate a map, but then we thought, we don't want to have to run through this every time we get more data. So we started discussing the idea of using Collector. And I had used Collector before for classes when I taught field trips. It's a really quick and easy way to record data for going to the intertidal, for example. But I hadn't really thought about using it for my research. One of the big benefits that I saw was the idea that it would all go into one geodatabase seamlessly. So we decided to try it out, and our basic approach was to use 2 different tablets, not that we had to, but just because of the time involved in entering the data. And we had 3 feature classes. One is for the trip. This is where we put the metadata so we don't have to enter the same stuff over and over, such as what boat we're on, what region, who the observers are. That way, we only enter that one time. We also have one class for all the observations of the marine mammals and another one for the boats. Those ones were developed with the same fields as we had in our original data sheets, and we tried to replicate that data sheet pretty much exactly, but also develop it in a way that was relatively easy to use in the field. And then we used a trip letter that went in to connect everything with that metadata. And the reason we used the 2 different tablets was, one, we'd record marine mammals, and one, recording boats, so that you could be doing both at the same time. So rather than just switch without knowing whether it would work or not, we decided that we should test it out. And so that's what we just did this summer. The good thing was we had Earthwatch volunteers. We'd have usually, there were 4 of us crew, plus up to 6 volunteers. So with 10 people on the boat, we could spread everyone out, and we could have people recording with our traditional paper method along with using Collector at the same time. After each day, we would validate our entries. So we'd pull up what we recorded on ArcGIS Online and compare it to the data sheet to make sure we hadn't made any mistakes. And we also kept track of those. And it looks, I haven't completely quantified it yet, but from a quick glance, it seemed like we had about equal number of errors. There were errors. Sometimes it was a typo. Somebody puts in 500 instead of 50. Oh my gosh. That's the end now? Yep. Oh my gosh. Okay, I'm so sorry. Let's go quicker then. Okay, comparison. Traditional method was faster in the field, easier for our volunteers who were not very comfortable with technology, and you can modify your entries right on the fly. Compared to Collector, which gave you instantaneous maps, saved a lot of time, it was much more consistent, and it gave us that seamless integration of long-term data, making analysis much easier. So we have decided that Collector was the winner in this, and we've now switched over. A couple quick lessons that we learned: the importance of using drop-down menus and making those in a logical manner. The first one you can see is not in any sort of format that's easy to find. Second one is alphabetical. much easier to figure out where your data is. Still need instructions and still need training for new people. And of course, verifying the entries while you still remember what you saw. Just a couple quick example analyses. These are some maps that we created using this big map that we now have, looking at blue whales compared to humpbacks over 4 different seasons. And we can do that very quickly. We could also do a quick hotspot analysis where you can see that they're separated in habitat. And these are things that actually were created yesterday very fast from my intern, who has had little GIS experience, was able to make these very quickly without much experience. Some things that we're working on are the track lines. We use an Android tablet, and we need to have a 3rd tablet running just with track lines. Right now, we're still doing it off of the GPS, but that's a relatively easy fix. And we are in the process of developing the dashboard. We do have a little bit of it up and running, thanks to some hard work from my support. But the idea is that we can get a quick view of what animals have been seen or what boats, and very summary statistics very easily. And this is just another example of a map that we created that, again, this was much more efficient compared to, I would estimate, we probably saved at least 50 to 70 hours over a 5-week time period by doing it this way compared to our traditional method. And I'm really excited to see what my students can now do with all of this data that's so much easier to access and analyze. And I would like to thank all the very many people who have been involved in supporting this.